All right, so now we're going to talk about Babylonian division. Babylonian system is base 60. One of the most amazing aspects of Babylonian arithmetic is that people could divide by 60. No, was the use of multiplication tables, specifically the table of reciprocals or multiplicative inverses. Division was performed by multiplying by the reciprocal. That was what I was saying in the previous video of division just being a special form of multiplication. You're multiplying by the reciprocal of a number. So if I'm dividing by 2, it's the same as multiplying by 1/2. Right? Babylonians were also well aware of the place value notation of fractional parts of a number. We'll use a semicolon to denote the sexagesimal point. Right? So it's base 60 rather than base 10, so instead of decimal. But it'll kind of serve the same purpose. You'll have the whole number part, then semicolon followed by a fractional part. So the place value table, we would have, the ones place, 60, that's really not the ones as we know, but the 60 to the 0th power, 60 to the first, 60 to the second. So the 60s place, the 3600s place, if you're going out to the left, then the 1/60th place instead of the 10th place, right? And the 1/3600th place instead of the 100th place if you're talking about a decimal system and so on, right? The Babylonian representation, so just a quick example, of the inverse reciprocal of 2. In this context, inverse and reciprocal mean the same thing. Reciprocal or the multiplicative inverse of 2 would be 1/2. But in base 60, it would be 30 over 60, the denominator serving as the base, right? So the way we would write that in Babylonian would be, if it's just the fractional part, 0 whole number, 30 on the sexagesimal part, all right? So I know it's kind of weird, but that's just sort of how it is. And it does relate to clock math and things like that, so there is applications of it. But the idea that there's 60 seconds in a minute, right, 60 minutes in an hour, so 3,600 seconds in an hour, for the sake of timekeeping. I mean, if you're using a digital clock, maybe you don't feel it as much, but if you grew up in the era that I did, and there weren't digital clocks on the wall, it was a regular hand clock. Like you got the minute hand, the hour hand. A minute feels like an awfully long time at the end of a school day when you're sitting in a classroom and you're watching that minute hand go around that circle. Right? So this is the math that corresponds with that type of idea. We have the historical context, which you can look through. The Babylonian table of reciprocals. Right? When you have a system of computation that's as complicated as this, it kind of makes sense to have a quick reference sheet, right? So that's the idea here. But we could, if we needed to, we could build all of these things. Our steps, division was performed by dividing the dividend. Again, that's the thing you're dividing by the multiplicative or with the multiplicative inverse of the divisor. Right, so we're multiplying the dividend. We're multiplying in order to divide, essentially, using the multiplication tables and tables of reciprocals. So instead of saying m divided by n, we're saying m times 1 over n. Right? So we're taking the reciprocal. But then that's where it gets interesting. We're going to convert the 1 over n to a Babylonian fraction using the table. All right, or if you want to do it by hand, that's perfectly fine. But if it's something that you could reference, then by all means. Multiply this fraction with m, all right? So that would be the dividend, making sure all calculations are in base 60, right? That's the interesting part of it, all right? So I'll just follow through this process here, and I'll carry out some of the operations. 42 divided by 9, we already know what the answer is supposed to be going in if we use a calculator. But remember, that answer is going to be in decimal form. It's going to be 4 2/3 roughly. But if you think about this as clock math, and we look at this in hours and minutes, hours, minutes, seconds even, you can say that we're looking at 4 hours and 40 minutes, which would be 4 2/3 hours, right? 2/3, that's not a 3, 2/3 of 60 is 40. All right, so when you're thinking about clock math, you're actually doing Babylonian multiplication or division, right? So we convert the 1/9 using the table. So we find 1/9 in here, right? That's, if we're going hours, minutes, and seconds, that's going to be 0 hours, 6 minutes, and 40 seconds, all right? Carrying out the multiplication, again, in base 60. So I'm going to do my 42 times the 40. That gets me to 1680. All right, that's this number here. But then we have to go to base 60. So let's pull that off on the side, because I sort of, in the text here, we're looking at sort of a hand wavy response to it. 1680 into base 60. Now you can do this one of two ways. You can kind of do it like we did for binary conversions with the hexadecimal and octal and all that stuff. Or you can just write it using powers of 60, whatever you feel more comfortable with. I can show both ways. If I do it this way, I'm looking at 28 with a remainder, so 60 times 28 is an even number, so it's a remainder of 0. And then if you continue on with that process, you're not going to get anything other than a remainder. So 28 divided by 60 would be 0, remainder 28. So this is my 28, this is my 0 in base 60. All right. So 1680 becomes 28/0, right? 0 being the equivalent of the ones place. It's very strange, but if you remember back into I think it was the first week when we talked about the different places for Babylonian, any number that's less than 60 is itself. Anything that's 60 or more is written as a base 60 value. All right, so that was, and I'll just kind of show you off on the side here, 1680 again. I would look at powers of 60. So we'd have 60 to the 0th, 60 to the 1st, 60 to the 2nd, all right? 60 to the 2nd power is 3600, that's too big, so that wouldn't be helpful. But what I would do is I'd look at my 1680s and say, well, how many 60s can I get in there? I can get 20 of those 60 to the 1st powers. Then plus, so I would have none of the 60 to the 0th powers, because 28 times 60 equals 1680. So the way we would write this would be 28 and then 0. All right. But if we were actually using the Babylonian symbolism, we would use those little angular looking figures. I'd have my 20 that way, and then I would have my, I need 8 of these. All right, so that would be 28, and then I would have nothing for the 0. All right, so we're not worried about the Babylonian notation or the cuneiform, but yeah, that's the connection. All right. Anyway, I have a 28 and a 0, so I'm going to leave the 0 here. I'm going to bring the 28 along. Then I'm going to do the 42 times the 6 and tack on the 28. That's going to get me 280, right? And again, we're doing that into base 60. So 280 divided by 60 is going to be 4, right? 6 times 4 is 24. So 60 times 4 would be 240. That's going to give me a remainder of 40. And then 4 divided by 60 would give me 0, remainder 4. So this is going to be equivalent to 4 and 40. All right, so the 40 stays here. I'm gonna change my colors up. So the 40 would go here, carry up the 4. 42 times 0 is 0, plus 4 is 4. Right, and so that's where our last entry comes from, and that's a whole number entry. Right, so this addresses where the 4 and the 40 come from. Right, and then from that we build it into the actual product, and you can see the relationship. Right. Yeah, and so you can see the example showing all those calculations, but I figured I'd show you in real time just so hopefully it'll make a little bit more sense. So if I were doing 11 divided by 3, so 11 divided by 3, that's the same as saying 11 multiplied, I'll use classic multiplication symbol, by 1/3. I go to my table. 1/3 if you don't recognize, but that's 0 and 20. All right, so we're taking 11 and multiplying it by 0 and 20. So 0 hours and 20 minutes. A third of an hour is 20 minutes. We're going to take the 11 and multiply it by that. Let me just write it over here. Just like we did previously, I'm going to take that 11 and multiply it by each component, right? So I'm just trying to think where I should write it. I'll just do it off on the side here. So I'll do my 20 times 11. That's going to be 220, but I need to get that over into base 60. All right, 6 times 3 is 18, so 60 times 3 is going to be 180. That's going to leave me with 40 left over. Then I'm going to take my 3 and divide it by 60. That's going to give me 0 with 3 left over. All right, so I'm looking at a 40 here, a 3 here. 11 times the 0 is going to give me 0, plus 3 is going to give me a 3. So I'll have, and just carry down the semicolon, 3 and 40. So 3 hours and 40 minutes if you want. All right. So it's just kind of balancing back and forth between the numerical conversion stuff that we've learned and also tying in this new way of approaching things. Not going to ask you to come up with the fractional values without the use of a table, but that's something that you probably should be able to do if you think about it in terms of hours, minutes, and seconds. But you could also see why certain numbers don't really fit with this. Like if I have like a 1/7, what's 1/7 of an hour? Like I don't know off the top of my head. I need a calculator. All right, so that there are exceptions to everything, and that would be an exception in this case. So now you should be able to move on to exercise set 2.3.